my team members are here too.
Yeah.
Okay, so let's get started. Hi, everyone. Thanks for joining us today in KubeVela's community meeting. And I saw some new people in the community. Do you mind to introduce yourself first? Like Richard?
Yes, I'm part of Team Warrior. I'm in a group where Lena King is like basically the team lead, and she's one of the OAM like initiative drivers for KubeVela.
Oh, okay. Yeah. And I post our Google Doc in the chat. So maybe you can you can sign up in the comment in the doc. Okay, let's get started. So in today's meeting, we're gonna have two parts here. So Da will first introduce the vela-prism dynamic API proposal. And after that, he will introduce the implementation after the dynamic API. So Da, can you share your screen?
Yeah, it's fine. Actually, before I share my screen, I would like to explain a bit more for the schedule. Actually, the dynamic API is the only topic I would like to talk about today. But since placing only one entry in the schedule is a bit easy and simple, so I separated them into two parts. So actually, they are the same. Yeah. So let's start with it. I will share my screen. Okay, can you see my screen now?
Yeah.
I switched to the PowerPoint. Can you see the slides here?
Yeah.
Okay. So actually today I would like to introduce a new technique we are developing, and since we have implemented some of the proposal, but the design is not fully decided. So it can be faster changing. So I will just raise the idea here and see some demo examples to you and show the basic idea of this new function. And you can add more ideas or opinions for the new features. For example, what you think it should be like and what you expect it to work for. So it's just an open discussion and not a very strictly feature introduction. So let me start with the new idea. So this idea is based on the aggregated API server. And I'm not sure if you have known for this technique in Kubernetes. And in KubeVela system, in the whole KubeVela architecture, there are actually two parts currently that uses aggregated API server. One is the cluster gateway, which provides multi-cluster access. And the other one is the vela-prism, which we extend the API to support some other Kubernetes resources, which is backends by some other APIs or underlying CRDs like the application resource tracker and the Grafana API. So the basic idea for the aggregated API is that in Kubernetes, we can actually extend the resource type even without a concrete custom resource definition. Actually, for the Kubernetes resources, we can treat it as some collections of special collections of some API interfaces, such as create a resource or update a resource or delete one resource. So actually, once you have implement those CURD interfaces, you will be able to add some new resources in Kubernetes. And those resources can actually be manipulated by the native tools, such as the kubectl and other UI system, I think. So one of the way we would like to extend our API server now is that since we have an abstraction layer in KubeVela, we have the abstraction layer which leverage the Q template to do the rendering job. And also we have the Q template engine in workflow step, which can execute commands and process in the workflow. So we can use the Q template to make the process as codes, and users can easily integrate third-party resources and processes into the system once they have put some templates inside. In KubeVela system, we usually call them X definitions. For example, the component definition and the workflow step definition. So that's for the core KubeVela parts we previously have. And recently, we have tried to extend the use of Q templates in the aggregated API server as well. In our cases, we extended into the vela-prism. So it can natively, you can actually use it as other add-ons you have in your KubeVela system, which is very easy to use. And so what we can achieve with that? So generally, if you have made some special Q templates in the KubeVela Prism, let's say if we place some config map to store the Q template, and let the template to identify how to render resources and how to decode resources, and then it will be okay for the Prism to provide extra resource APIs to the Kubernetes, so that there will be additional resource appeared on the Kubernetes system. So let's give a very simple example. For example, we usually have a very long description for the deployment, as you can see, and it has lots of fields in the deployment part. But most of the time, we only need to have some very simple setup for the deployment. For example, we just want to some simple container, and we only want to have like one replicas, and we do not care too much details for it. For example, how the resources are allocated, and how the timestamps are set, and how the labels are set in the deployment. And you can see that there is lots of details in the deployment status as well. So this deployment spec and status, the YAML of the deployment can be very large. And in KubeVela application, we actually have one component type, which is called web service. And web service actually makes some abstraction to the deployment, and you can only specify the image part and use it in the application. And then the application will create the deployment and manage it. So in some cases, the application part might be a bit heavy to use because we have installed some controllers inside. But what if we do not want that heavy controller, and we would like to have more direct ways to do the abstraction? So in the Prism, we can actually create two Q templates. One is the decoder templates, and the other is the encoder templates. So each coder takes the parameter part, and another field is the output part, which if you have seen the component definition, these things are very similar, and you will be familiar with that. So the parameter part actually defines the input of the template, and the output part will return the result of the render template. So for example, if we have defined some special resource called web service, and it only exposes very simple fields such as the image part and the replica part, and we can let the Q template to render the web service into a full deployment underlying. So this is what encoder do. And after that, we can have a decoder which helps users to decode the deployment into the web service. But a very simple question is that not all the deployment can be mapped into the web service. So there is actually some restriction. For example, we only support one container in such web service typed object. And so if you have defined those encoders and decoders, you will be able to get a very native Kubernetes resource called web service. And you can actually manipulate with kube control, like kube control get web service or kube control edit web service. And the underlying part will be to create the deployment and update the deployment as well. So there will be no extra overhead for the storage part. And it can be very transparent. So if you have already a lot of existing deployment in your system, you would not to create extra web services to represent them. With the aggregated API, you will be able to directly get those web services that's upon those deployment. So let's see a very detailed example, and let's go to the details for the let's say the web service. And for example, we go to the encoder part, and you can see that the parameter of the encoder is actually a configuration for what you want the web service to look like. So you can set the fields you would like to expose here, and the output part will be the queue part to render those input part into a very detailed deployment. And the decoder part actually is the reverse process that converts the deployment back into the web service. So let's make this config map into the system. Okay, so let's create this config map inside the system. Okay, I think the network is a bit slow, but it looks fine. So now we have put those templates, the encoder queue template and the decoder queue template inside the Kubernetes system. And now you will be able to get a new type of resource. Called web service. So if you have deleted that config map, you will see this one will disappear. So once it's created, the type appears. And when you have those this new type of resource, you could actually use kube control to use get web service. But I think there is no deployment in the default namespace. So let's create some. Okay, well, I have a very simple web service, and this web service is named as Nginx example, and what it's do is to set the image and the replica. And actually, the selector part can also be encoded as part of the template, but I just expose it here. So this part can actually be simplified. Okay, let's put this web service in our cluster. I think the network is a bit slow, but it works. Okay, so we have placed that web service in the cluster, and we could get web service now, since it is placed in the default cluster, default namespace, and we can use all the things you would like to have in the kube control, and you can actually do the edit work. And you will only need to care about those simple fields. Let's say make it 3 replicas. Okay, so this one has been updated, and let's see the web service now. Okay, you can see that the ready replicas is 3 now. So if you go to the underlying deployment, you will see that there is actually a deployment with exactly the same name appears in the cluster. So this is what the web service underlying looks like. And so let's say we already have lots of predefined deployment or pre-installed deployment inside the kube system. And we can actually use the kube control get web service -n kube system. And we will see that there is other pre-installed deployment represented as the web service as well. So that's how this one works like. And we can do more complex things. For example, we can do some complex rendering job for the config map or the other very detailed configurations. And we can make more arbitrary abstraction layer between the resource and what users interact with. So this is what we would like to do for the extension server. And this is by far what we have implemented and the basic idea for the dynamic API in vela-prism. But there is more things we would like to do for that in the future. For example, as you can see that we have the workflow engine that can execute commands and process inside the Q templates. So if we move this idea into the dynamic API, it is possible to create some special resource. For example, let's say we create resource called the let's say we create a resource called MySQL table. And the MySQL table might be something that works as a Kubernetes resource representation to the underlying MySQL table inside the my databases. And so you only need to implement the interfaces in your Q templates. For example, when you get those tables, it will use the MySQL query sentences to get the tables back. And if you want to modify the table, you can actually set up the related functions behind it. So what Kubernetes user will see is that they can use the MySQL tables in the as the YAML file or the Kubernetes resource objects with the existing Kubernetes tools such as the kubectl and other Kubernetes YAML editors, and they will be able to directly modify or get or see the underlying tables in your MySQL databases directly from your Kubernetes control plane. So this is what it might work like in the future. And the idea, the main idea is to use the Q template to extend the API server of the Kubernetes. So that's all for today's introduction. And if there is any questions for the proposal or the ideas you would like to share, just welcome to it. Yeah, thanks all.
Yeah, thanks for demoing that. So the Q templates are now dynamic. So and they exist inside the dynamic API server component. So before that, how did it work before? They kind of got frozen into CRDs before and could not be dynamically changed. So with this approach, you'll be able to dynamically change the way that things are constructed.
Yes, exactly.
But will there be versioning? What about does it matter so much that if the templates are changed while we have resources already existing?
Okay, that's a very good question. So one of the key idea for the Q templates as the API here is that it actually do not create anything. So there is no extra overhead inside any storage, no matter what you stored in the etcd or other CRD objects or other database or other you would like to say they have some versioning things. So they are just these Q templates are actually interfaces or converters to the underlying objects. So so once the underlying objects, their schema are not changing, if you change the Q templates upon it, the user will only see that the view of the underlying data changes, but the data will not change. So there is no data compatibility problem in the API. So this is actually one of the possibly this is one of the advantage over directly using CRDs. Because CRD, once you have a CRD, there might be some problem for syncing the custom resource data and the some outside third-party system storage. So it can treat as a proxy to the underlying data.
Okay. So it's not introducing a problem, and it may in fact be solving it. But you have to code your templates correctly. But you're not going to be
yes. So if you have a bad encoder, I think the implementation now will throw some very hard understanding Q error messages. So it's not very user friendly once you have a bad encoder. But I think one of the things you could use to alleviate this problem is that since these parts are purely by far they are purely Q rendering process, so you can actually put the encoder and the input of your object in some Q file and directly use the Q tools to evaluate, and you will see how the errors are thrown and which fields are conflicts. So they are actually Q native. Yeah.
Right. So it should be pretty easy to set up a huge set of tests to make sure everything's running correctly.
Yes.
Great. Thank you.
Thank you. And also this, since this one is still in proposal now, and we are continuously designing it and improving the implementation. So there is no existing documentation by far, but I think once we have made some more progress on it, we will have more proposal documentation and technique introduction documentation to that. Yeah, so that will make the explanation and the reading easier.
Okay, so any more questions, or it doesn't have to be related to the topic, anything that you want to discuss?
Okay, I think I can add another two little notes to the community meeting. One is that I think we have just held a presentation on the TAG application delivery community meeting, and the presentation will be, I think, will be recently uploaded to the YouTube and released in the official documentation site. So if anyone is interested in the introduction and how we present KubeVela to the application delivery group, and you can refer to that material later. And another things I would like to mention is about some of the techniques we are developing in KubeVela core controller now, and which we might be able to discuss it in the next community meeting, is that we are making some progress on taking over resources in KubeVela application and make read-only application in KubeVela system. So these things are focused on different parts. And the takeover part is that if you have something already exist in your Kubernetes system and you do not have an application in your system, and with the takeover feature, you can let the application to take over those resources that are not originally managed by itself. So it will be helpful if you want to migrate some Kubernetes system to use KubeVela application to manage your resources. And another feature is that the read-only feature, it can be used to set up some auxiliary tools. For example, we have some application level observability, which you can use. But before you use that application level observability, you need to set up some application to represent the resource you would like to monitor. So if you already have resource in your system, but they are not managed by a very concrete application. So with the read-only application, you would be able to set up a application which do not modify those resources, but can set up a collection of rules that can provide the information and monitoring tools for the underlying resources. So it can be seen as a logical application and organize resources more flexible. Yes, so that's what we are making progress on, and I think we will share it in next community meeting.
That would be great, Sampai, because migration of existing applications, existing resources into application would be the biggest solution we have for adoption of KubeVela.
Yeah, yes. Actually, what we have doing now is doing something very simple as a start. So it might not be able to cover all the adoption details and scenarios directly, but we are happy to your scenarios and to make that adoption capability programmable and practical in your scenario and make it more functional. Yeah.
Cool. Thank you.
Thank you.
Okay, so if there's no more questions, I think we can end this meeting. And thanks for everyone who's joined us today. And the recording of the video will be uploaded to the YouTube channel. So bye.
Goodbye.
Bye.
Thank you.
Thank you.